At first, I want you guys to show the architecture which Skython AI is built upon. Um, just wait a second, and this is the GitHub. I'm basically trying to show you guys the README file because it has the architecture. There it is, and I will yes. So a student will ask Skython AI a question, and the mentor engine at its core is a multi-agent orchestrator. It routes every student's message to the right specialist. So it has the teacher engine. Wait a second. So the mentor engine just passes the query to the teacher engine that formats responses using a strict three-part template, which is analogy, syntax, and then exercise. The curriculum engine that tracks mastery across topics using an SQLite database, and a secure sandbox that lets students run Python securely. Now these are the skill registration. You can see over here, hint skill, everything over here. You can see it. um, all right, so tying it all together is the MCP server, the model context protocol, which gives the LLM controlled access to tools to run sandbox, query the student's progress, and analyze code quality. And also, I forgot to mention the front end is a Gradio UI served locally at your local host. So, no internet, no cloud, zero data leaves the machine. So, now we'll be talking about the MCP server, modern context protocol. Let me just open it first. Uh, so, here it is. Now over here you can see the deck setup and the log MCP request. So it's basically the server keeps track of its own history. It uses a light in-memory queue to store 100 most recent tool requests, and like every time a tool is executed, it logs the timestamp, the tool name, and whether it succeeded or failed, ensuring you have real-time observability. So that's pretty much the whole function of the server. Now let me show you the fast API section real quick. um, so here it is. So this thing is built with the fast API, which creates a lightweight high performance REST API interface. Now the main job is to allow Skython to discover and interact with external tools. Now these three are the API decorators. The architecture relies on a simple three-part contract. The first is the discovery, the get root that lists all tools that AI can use. Second, the brain of the operation, a post root to execute those tools. It basically receives the tool's name, runs it through an executor, and safely catches any error. And finally, get root to fetch the execution logs. Right. So how does an AI know what it can actually do? It starts with schemas. Here we define a strict list of tools like execute Python code. You can see the MCP tools list over here, and yeah, there we go. This is the execute Python code over here. So it details exactly what inputs the AI must provide, and this is the contract between the AI and our system. So moving down, you can see the MCP tool executor. So I'll show you the arguments. Like, so basically to run these tools we use the MCP tool executor class. Notice how its initializer pulls in various subsystems: a memory manager, a curriculum engine, a secure sandbox. This class acts as the central brain, connecting the AI to the app's core logic. So yeah, now moving a little below it, I'll show you the see this is the def execute self. When the AI asks to use a tool, it hits this execute method. It acts as a traffic cop, using a dictionary to map the requested string. name like get students mastery directly to the internal Python uh, method that handles the logic, safely catching any error along the way. So yeah, and moving to the next, you can see finally here where the magic happens. uh, in the execute Python code method, it extracts the code provided by the AI and passes directly through the self sandbox. The result, including standard output or any error, is then packaged up and sent right back to the AI. So now I'll be talking about the security system in Skython AI. Since students run actual Python code, security is very critical, I feel. And Skython has two-layer security system. One sanitizer and second is validator, and I'll be talking about sanitizer, which strips dangerous patterns from input before it even reaches the sandbox, right? So here you can see the injection patterns over here. I feel when building a AI application, security must be your top priority. So this code sets up a frontline defense against prompt injections, like by defining a list of strict regular expressions. The system automatically flags common attacks, like if someone tries to hijack the AI by telling it ignore previous instructions or forget its personnel, it will not work over here, since we have this thing as our defense. And let's go a little bit down, and here you can see the sanitize pipeline. So basically, to handle these threats, every piece of user input is forced through this sanitize pipeline, right? So it follows strict rules, clean white space, and most importantly, truncate the text. Now I'll, like, if I go in detail about it, I think I should say, if an input exceeds our maxed input length, it gets sliced down immediately, preventing token exhaustion and massive copy paste attacks. So yeah, that's pretty much it. Now if I go a little bit down, uh, so this is the neutralize injection block, and here you can see the for patterns in injection, and text equals pattern dot sub. So finally, it's the core neutralization step. The strip loops through all those attacks pattern we defined earlier. So let me open the validator file now. uh, there it is. And yeah, so here you can see that the import AST over here. So this is basically before running AI generated Python code, you have to ensure it's safe. So this script basically handles uh, pre-execution security validation using Python's built-in AST module. And by creating a custom node visitor, the system can deeply inspect the code's structural tree before a single line is ever executed. So let's scroll down a bit, and here you can see the visit call. Oh wait, yeah, so like as the visitor walks through the code, it hunts on threats. It stops unauthorized module imports and blocks dangerous built-in functions. So here you can see the function name, and yeah, so like critically it intercepts attribute access to global dunder variables, like here you can see like globals or built-ins. So these tightly seals of the most common avenues attackers use to escape a sandbox. So yeah, uh, it's so let's scroll down a little bit, and I will talk about the validate code. So here you can see dev validate code str. So like it all comes together in the validate code function. The raw string of codes is first passed into an abstract syntax tree. Our security visitor then walks that tree from top to bottom. If it finds zero violations, the code gets a green light. If it spots a threat, the code is stopped and dead in its track. So that's how like the whole security thing works altogether.